All right, Chapter 9, Problem 8. We have a soda can that's 0.14 kilos. It's 12 centimeters tall. It's filled with 0.354 kilos of soda. Then we're going to drill small holes in the top and the bottom. If we drill just a small hole in the bottom, it'd take a long time for this to drain out because air wouldn't be able to make it in very well. We're going to drain the soda. And the question is, what is the height h of the center of mass of the can and contents? Well, A initially. Okay, so let's think of where is the center of the mass of the soda, because we're calling the height of the soda x, and that's on down in here somewhere. X is the height of the remaining soda. Let's spell that correctly. X is the height of the remaining. Does that imply that remain end is a, never mind. X is the height of the remaining soda. And so part A is easy. Right? We have a can that's uniform in terms of rotationally uniform along the y-axis. The center of mass of the can is going to be at 6 centimeters, and when it's completely filled with soda, the center of mass of the soda is going to be at 6 centimeters. So A is pretty easy in that h equals 6 centimeters. All right. All right. After the can loses all the soda, the soda is no longer a factor. And now we're looking again at where is the center of mass. Well, the center of mass of the can by itself is at 6 centimeters. Okay, so center mass starts at 6 centimeters. Center mass winds back up at 6 centimeters. What happens in between? All right? What happens to H as the soda drains out? All right, when the center of mass, I'm going to put in here H, right? Okay, so what happens to the center of mass? So the center of mass is, okay, total mass. All right, so here we have to come up with a few things. Center of mass is going to be 1 over the total mass times the center of mass of the can times its mass. All right, so the center of mass of the can is always 6.0 centimeters times where its position or its mass, 0.140 kilograms, right? All right, plus, okay, the center of mass of the soda. If x is the height of the soda, what we're doing is we're looking at center of mass of the can, where is it, plus times its position, the center of mass of the can times its mass, plus the center of mass of the soda times its mass. Now the center of mass of the soda is at x over 2, right? But what is the mass of the soda? Well, the mass of the soda is going to be the fraction of the soda left. And the fraction of the soda left is x divided by 12 centimeters, right, times 0.35 kilograms. Does that make sense? The mass of the soda left in the can at any point is the height of the soda divided by 12 centimeters, right, times 0.354 kilograms. It's just a fraction of the initial soda that's left. And this means our mass, right, our total mass is 0.140 kilograms plus x over 12 centimeters times 0.354 kilograms. All right, so H is 6 times 0.14. Let's just go ahead and go 6 times 0.14. So 0.84. 0.84 kilograms centimeters plus x squared. All right. the next term is 0.354 0.354 divided by 24. All right, 0.354 divided by 0.354 divided by 24. So 0.01475, 0.01475, and that is going to be kilograms per centimeter squared. Right? No, kilograms per centimeter, pardon me. Kilograms per centimeter times x squared. Okay, now all of this is going to be divided by. All right, so 0.354 divided by 12, 0.0295. So all this is going to be divided by 0.184 kilograms plus 0.0295 kilograms per centimeter x. So that is the equation for the height of the center of mass as the soda drains out, right? What happens to H as the soda drains out? So we got this quadratic on top, linear term on bottom. X starts out at 12 centimeters. So what does that mean? That means at 12 centimeters, this bottom term is just 0.14 plus 0.354, which is the total mass. So that makes sense. And that drops down linearly with X. And then the weighted position of the soda goes as x squared. All right, x squared. And so this in the bottom is going to be kilograms. This in the top is going to be kilograms centimeters. We're going to end up with centimeters. And this is the expression for the height of the soda can, height of the center of mass as it drains out. Okay. If x is the height, now we're on to part D. If x is the height of the remaining soda in a given instant, find x when h reaches its lowest point. So in D, what we're really looking for is dx, dh, dx equal to 0. Right? We're looking for that minima where dh, dx equals 0. So what is dh, dx? Right? All right. So we've got the top term. So it's I'm going to go f1 divided by f2, right? So 1 over f2 times df1 dx, all right? Plus, all right, so f2 I can write as f plus f1 times dx of f2 to the minus 1. So 1 over f2 times df1 dx. All right, ddx of f2 to the minus 1 is minus f2 to the minus 2 times plus f1. Oop, I can't type. Times. Okay, so the derivative, this piece right here, derivative of f2 to the minus 1 is going to be minus 1 over f2 1 over f2 squared times df2 dx. Okay, so this is the how we're going to find this derivative, right? Oh, I'm sorry. I should put dx here. All right. So h I'm going to call f1, which is the numerator, divided by f2, which is the denominator. So ddx of f1 over f2 is 1 over f2 df1 dx times f2 ddx of 1 over f2. Now 1 over f2 is just f2 to the minus 1, so that works out to be this second term here. ddx of 1 over f2 is minus 1 over f2 squared times df2 dx. Okay, so we have f1 is 0.84 kilograms centimeters, right, plus 0.01475 kilograms per centimeter times x squared. So df1 dx is, okay, the first term goes out, the second term 2 times 0.147, 2 times that, 0.0295 kilograms per centimeter times x, right? So that is that's df1. Okay, df2 dx is, okay, let me put in here what f2 is. f2, right, is 0.184 kilograms plus 0.0295 kilograms per centimeter times x. So df2 dx is just this second term, 0.0295 kilograms per centimeter. First time goes away, all that's left is this second term. So let's start putting this all back together. dh dx equals 1 over f2 times df1 dx. So df1 dx is this. Divided by f2. Okay. Minus f1 over f2 squared f1 f2 squared times minus f1 over f2 squared times df2 dx. And we want all of that equal to 0. Okay. All right. Now, one of the things we have to remember when we're looking at this is that both minima and maxima satisfy dh dx equals 0. All right. So let's simplify this a little bit. I'm going to divide through by the 0.029, right? And that's going to give us, this one's going to cancel out, that one's going to cancel out, and so we'll be slightly simpler in our expression. Right? So that becomes just x. That goes away. Okay. As we try and simplify this to get down to something usable, right? I'm going to multiply through by this denominator. All right. Well, I'm going to do two things. First, let's divide out. Nope, that's a plus there. Pardon me. That's a plus. All right, so let's multiply by this squared. So if I'm multiplying by that squared, this one, this becomes x times that. That one goes away. Right? That's going to go away. That equals 0. Excellent. Excellent, excellent, excellent. Okay. So we have a linear term, we have a quadratic term, we have a linear term and a quadratic term over here. I'm hoping I'm keeping track of all my math correctly on this. Okay, so 0.18, I'm going to drop units at this point just to make my life a little easier and yours a little easier. So we've got minus 0.85, right, plus 0.148x, right, plus, okay, we've got two x squared terms. We got 0.0295 x squared plus 0.01475 x squared equals 0. All right, back up a sec, just make sure I've done everything. I divided by this term here, it goes away there and here, and then I multiplied by this term squared, which left me with 1 in the numerator here and none there. That minus sign, I erred. That minus sign applies both here, applies there as well. Okay, so I'm glad I caught that, which makes that a minus sign right there. Okay, there we go. So 0.0295 minus 0.1475 is, I did something wrong there, didn't I? 0.0295 minus 0.1475 is minus 0.118. So minus 0.85 plus 0.148x minus 0.118x squared equals 0. Okay. And now we're just going to stick in quadratic formula, right? And we got b equals 0.148. We have a equals minus 0.85. We have c equals minus 0.118. Right? All right. A minus 0.85, B 0.148, C minus 0.118. And the quadratic formula says I need minus B. All right, I'm going with the plus root first, square root of B squared minus 4 times A times C all divided by 2 times A. What did I do wrong? B 22, 21, 23. Right. Right. Okay. Okay, so I'm going to go with the other route. Clearly, I have erred somewhere. Let me go back and take a look. Okay, I made two errors along the way. One is when I typed in 0.01475, I typed in 0.1475. So this should be, in fact, a plus 0.01475. All right, the other error I made is that A is the coefficient of the x squared, 0.01475, and C is the constant, 0.85. All right, so once I do all of that, I get 4.08 centimeters. X equals 4.08 centimeters is where dH dx equals 0. Now there was another obvious one up here, which was when x equals 0, we also get this satisfied, but that is in fact a maxima. That's a maximum, and so the minima occurs when x equals 4.08 centimeters. Okay, so why would that be the minima? All right, what happens at 4.08 centimeters? 4.08 divided by 12 times what's our mass of our soda? 354, 0.354, 0.354. Right? So at 4.08 centimeters, the mass of our soda has dropped below, at 4 centimeters, and x equals 4 centimeters. The mass of our soda has dropped below the mass of the can. All right? And as it continues to fall past this point, and once it drops below the mass of the can, where does it do that? Once it does that, it has less weight, and eventually the weight, and by weight I mean this is a weighted average, it has less weight in the weighted average, and the can becomes a dominant term in the sum of the mass times distance formula. Okay, so after some stumbling, here we go. This is it in the end. X equals 4.08 centimeters. All right, that's it for problem 8. Problem 8.